In this next example, the formula is f equals g times m1 times m2, all divided by r squared. And we need to rearrange this to make r the subject. Now the first thing we should do here is to try and get rid of the r squared in the denominator, because we're trying to make r by itself. It's really hard to make r by itself if it's down in a denominator. So the first thing we do is to multiply both sides by r squared to get the r squared up in a numerator position. Just a note about m1 and m2. They're subscripts. They're not powers, they're just labels. They're markers. In this case, with this particular formula, it actually means they're different masses. So this means the mass of one object, and this means the mass of a second object. So let's have a look what happens when we multiply both sides by r squared. The r squared on this side cancels down to 1 and leaves g m1 m2. And next to the f we have r squared. Now we want to get r by itself, so what we need to do is to get rid of the f that's sitting right next to r squared. So we divide both sides by f. Now at the same time we can get rid of the square by taking the square root of both sides. So first we divide both sides by f, and then second we take the square root of both sides. So here we can see where we've divided g m1 m2 by f, and here you can see what happened when I took the square root of both sides. Once again, because I haven't been told the context of the question, whenever I take the square root, it is a positive answer and a negative answer, shown by this symbol. We're asked to find r when g is 18, when m1 is 6, when m2 is 5, and f is 16. Remembering there's a multiply between these terms here, we replace each letter for its number. And we end up with r equals plus or minus the square root of 18 times 6 times 5 divided by 16. We can get our CAS calculator, or we could cancel down first. I've decided to cancel down first. Here's how it works. 2 goes into 18 9 times, and 2 goes into 16 8 times. Now the 6 and the 8, 2 goes into those two numbers as well, 2 goes into 6 3 times, and 2 goes into 8 4. Try it yourself and you'll see that cancelling down. Now I can reach for my CAS calculator and enter it into the calculator, and I end up with the exact answer of r equals plus or minus 3 root 15 over 2. This is the exact answer. If I want a decimal answer, it's only an approximation, so I have to round it off. And I'm putting it in my calculator and using blue enter, I end up with plus or minus 5.81 to 2 decimal places. Again, sometimes you might have to round it off to more or less, depending on what the question is asking for, and sometimes you have to make your own decision over what's appropriate to round off to. Here's another example. The formula is G1 equals R2 squared over R1 squared times G2. The instruction is to make R2 the subject. Now remember the G1, the G2, the R1 and the R2, those numbers are just markers, they're subscripts. It's telling us that G is the same sort of thing, but this is one G value and this one over here is a different one. In the same way, R is a similar sort of quantity, except this is a different R quantity compared to this one. These two here, being superscripts, means that that quantity is being squared. Alright, what do I do first? Well, the best thing to do is to divide both sides by G2. That's because this G2 is multiplying this fraction. and the opposite of multiplying is divide. So we end up with G1 divided by G2, written as a fraction, equals R2 squared divided by R1 squared. Now there's a lot of different ways to proceed from here, but one quite efficient way is to notice that both R's are being squared. And because that's happening, we can actually take the square root of both sides. That'll make this square disappear, and also this square will disappear, because we've undone them. So taking the square root of both sides, we're left with R2 over R1, both squares are undone, and on the right hand side, once again, we have two answers, a positive and a negative square root of G1 divided by G2. Now it's quite easy to get R2 by itself. It's being divided by R1, so the inverse operation is to multiply both sides by R1. So we can then flip it around as well. When we multiply R1 on this side, the R1s cancel out, leaving R2, and we're left with R2 equals plus or minus R1 multiplied by the square root of G1 over G2. Now we're asked to find R2 when G1 is 9.8, when G2 is 10, and R1 is 20. So in the formula, we replace those variables with their numbers. We end up with R2 equals plus or minus 20 multiplied by the square root of 9.8 over 10. Now you can reach for your CAS calculator and it will give you the exact answer, but some people might recognise that 10 goes into 9.8 and gives us an answer of 0.98. Now some of you can recognise that 0.98 is 2 times 0.49, and 49 is a perfect square. So if I take the square root of 49, I end up with 7. In the same way, the square root of 0.49 is 0.7. Anyway, if you don't follow that at the moment, we can just use our CAS calculator. And we end up with R2 equals plus or minus 14 root 2. Again, we can round this off as a decimal approximation. Whoops, what's going on? And that approximation to two decimal places comes out to plus or minus 19.8.